What is the scientific notation? It's a quantity expressed as a product of a number between 1 and 10. What does this mean? If we have this number here, and we want to express in scientific notation, it will be a number between 1 and 10, but with powers of 10. So the number will be 1.5, which is a number between 1 and 10, times the power of 10, which is to the 5th power. Here's a little tip. When we express numbers in scientific notation, we will always have a decimal and a number to the left. Decimal and number to the left. We will use this to help us understand scientific notation. It will help us avoid some mistakes. To understand scientific notation, let's understand first the powers of 10. Here we have two examples, 10 to the 4th, 10 to the negative 4. This here, the 10 is the base, and the 4 is the exponent. The exponent tells us where to move. When the exponent is positive, we move to the right. When the exponent is negative, we move to the left. The exponent in this example is positive, so we need to move 4 places to the right. Here is our number. Decimal, 1 digit to the left. Decimal, 1 digit to the left. Let's move 4. 1, 2, 3, 4. 1, 2. So this is 10,000. If we want to express this in scientific notation, decimal, 1 digit to the left, we have 1, but we need to get to the other side. We need to move to the right because this is a big number. So 1, 2, 3, 4, and to the 4. As you can see, this makes sense. Now, the next example is a negative 4. The exponent is negative, so we need to move to the left. Here's our number, decimal, 1 digit to the left. Let's move 4. 1, 2, 3, 4. Decimal and 1 digit to the left, which it will be 0. 1, 0, 1, 2, 3. So this is 0.0001. Now, let's express this in scientific notation. Let's use this over here to express this in scientific notation. Decimal, 1 digit to the left. That's 1. But we need to move until we get to this final decimal here. So let's move 1, 2, 3, 4. We're moving to the left. So when we move to the left, the exponent is negative. Let's express these examples in scientific notation. Let's solve for the first one, 200. Here's our little tip. Decimal, 1 number to the left. And numbers are expressed as a product of a number between 1 to 10. Let's solve for the first one. Decimal, 1 digit to the left. That's 2. We're moving to the right because this is it's a big number. 1, 2. That would be cube, 10 cube. Let's solve for this one now. 5,000. Decimal, 1 digit to the left. And this is a big number, so we're moving to the right. So that is 5. Let's move to the right. 1, 2, 3. It's 10 to the 3rd power, or 10 cube. Now let's solve for this example here. Write it down here. We have our decimal, 1 digit to the left. Decimal, 1 digit to the left. That'll be 8.5. But let's move until we get here. Let's move 1, 2, 3, 4. That'll be 10 to the 4th power. Now let's solve for this other example, 3 million. Let's express 3 million in scientific notation. Our decimal and 1 digit to the left is 3, and powers of 10. 1, 2, 3, 4, 5, 6. Be 10 to the 6th power. Now let's express these numbers in scientific notation. As you can see, these numbers are small numbers, so we will be moving to the left. The previous one were big numbers and we were moving to the right. Let's solve for the first one. Let's express 0.2 in scientific notation. Here's our little tip once again. Decimal, one number to the left, and we express them from numbers between 1 to 10. So our decimal place will be here, and the number to the left is 2. That'll be 2, and we need to try to get to this decimal place. So we move to the left 1 place. That'll be 10 to the negative 1. Be careful with the exponent. We're moving to the left. The exponent tells us that we need to move to the left. Next, 0.005. Our decimal will be here. That's the digit we need to the left. One digit to the left. That'll be 5. And we need to get to this decimal. So let's move 1, 2, 3 places to the left. Negative 3. Let's solve for the next one. 0.00063. Decimal and one digit to the left. Decimal, one digit to the left. We have 6.3. Now, we need to get to this decimal. So we move from here, 1, 2, 3, 4. 10 to the negative 4. Now, our final example here, 0.000015. Once again, decimal, one digit to the left, we have 1.5. The powers of 10 will be, let's move to the left, 1, 2, 3, 4, 5. That'll be 10 to the negative 5 exponent. Now, let's express these scientific notations to normal decimal numbers. Let's work on the first example. Let's look at the exponent. The exponent is telling us to move 5 places to the right. So we write our number 1 and we move 5 places to the right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our final answer in normal decimal number is 100,000. Now let's work on example number 2. 2 times 10 to the cube. Now, the exponent is positive, so we need to move to the right 3 places. 2. That's 3 places. 1, 2, 3. So our answer is 2,000. Let's work on problem number 3. And in this case, we have a negative exponent. It's negative 2. So when the exponent is negative, we move to the left. So here's our number, and let's move to the left 2 places. 1, 2. Decimal point, 1 digit to the left, which is 0, and final answer is 0.032. And for our final example, 2.5 times 10 to the negative 6. As you can see, it's a negative exponent, so we need to move to the left. 2.5, move to the left 6 places. 1, 2, 3, 4, 5, 6. Decimal point, digit to the left, right, the zeros. 1, 2, 3, 4, 5. So our final answer is 0.00001234525. That's how we use the scientific notation. Now, if this video was helpful, please leave a comment, and thank you for watching.